Okay, so we finished one example of law of sines. Let me do another. Okay, um, so this one, and by the way, a problem's not going to say use law of sines to blah blah blah. It's just going to say solve the triangle, and so it'll just say something like solve the triangle given by, and then they'll give you some information. So they'll say capital A is 60 degrees. They'll say little a is 9. And they'll say, little b is 10. Now, you should always draw a picture, okay? So, here's a triangle. Little a is 60, or big A is 60 degrees. Little a is 9, because that's across from big A. Little b is 10. Here's big B, here's big C, here's little c. If you draw your triangle a little different, maybe you put B on the sides and A vertically or whatever, not a big deal. The most important thing is just to maintain things being across from each other appropriately. That's the thing that really matters. So just like before, we will solve for the only thing we can solve for. If you look at the pair of C's, you have two unknowns. Avoid that. So we want to use the pair of A's that we know, and then the pair with the one unknown with the B. So we're going to find big B first. So to do that, I will do sine of 60 degrees. And normally I would say go ahead and evaluate that using the unit circle. I mean, 60 degrees is, what is that? Pi over 3 in radians. So you could evaluate that, but we're going to use a calculator in the end anyway, so it doesn't really matter. Sine of big B over 10. Now, just like before, I want to solve this equation for sine of big B. So I'll multiply by 10, and I'll get that sine of big B is 10 times sine of 60 degrees divided by 9. So then, therefore, sine B, well, that's sine inverse, and I like writing arc sine for that. Arc sine of 10 times sine of 60 degrees. Don't forget to write DEG for degrees, divided by 9. And I get an answer, and of course report the degree answer here, 74.21 degrees. Now, that is one solution. That is in quadrant 1. But as the discussion in the last video showed, and if you don't remember, go watch it, we also have to consider a second possible B. We have to consider it. We don't have a choice in the matter. So we have B2, and that would be 180 degrees, and I explained why that was in the other video. So we have 180 degrees minus this value we just found. Okay, so the value we just found was 74.21 degrees, and if we calculate that, what are we going to get? We're going to get 180 minus 74.21, and we get an angle value of 105.79 degrees. Now the question is 105.79 too big or too small to fit? I shouldn't say too small, too big or small enough to fit into this, what we know already. So I have to think, is this angle plus this angle bigger than 180? Because the sum of the angles in a triangle in the plane is 180 degrees. Well, it's easy to check that, right? I mean, you don't even need a calculator, really. It's 165.79. That's smaller than 180 degrees, this value. So what's that mean? That means that this is also a possible answer, a possible value that B can take. So what happens is, essentially, this information does not uniquely determine a single triangle. There are in fact two different triangles that obey this given information, and we have to find both of them. So, usually I split this into two. So we'll get two solutions. And the first solution will come from taking B is 74.21 degrees. The second solution will come from taking B to be 105.79 degrees. Now, luckily, we won't have to worry past this, because once I know angle B, whatever of the two I'm picking, I automatically get angle C without trouble. The only reason we had two is because we use law of sines, but we'll use the fact that the sum of the angles is 180 to find big C. So first thing I'm going to do is find big C, and I'm going to do that in both sides. Okay. Now they'll both have different answers, of course. So I'll get 60 degrees plus, so I'm going to use the fact that this angle plus this angle plus this angle is 180 degrees. So I'll get this plus big C is 180. So then that means that big C is 180 minus 60 minus 74.21. Well, we'll go ahead and compute that. Minus 60 minus 74.21. And I get an answer for big C of 45.79 degrees. And then the next thing I'll have to do is find little c. Okay. Let me go ahead and find big C over here. In this problem, I have still the 60 degrees from the A, this one, but then I have this as my B, and then I have big C there equals 180 degrees. So again, I'm going to subtract to get the value of C. So I'll subtract 60 from both sides of that equation, and I'll subtract 105.79 from both sides of that equation. And I'll get an answer of 14.21. So you see on this one, the angle C was a 45-degree angle, and this one is a 14-degree angle. Very different structure in the triangle. So let's find little c in both cases. Now, we're forced to use law of sines for this, but we will not be solving for an angle. We won't be taking the inverse sine like we did here. We'll just be doing algebra to solve. So by law of sines, again, we have sine of 60 degrees over 9 is sine of big C, which is 45.79 degrees, over little c. And just like before, I flip and multiply. I'll take the reciprocal of both sides, so I'll get 9, leaves yourself some space, over sine 60 degrees is equal to c over this thing, this sine, which I'm going to multiply to the other side. So sine of 45.79 degrees. And if I compute that, 9 times sine of 45.79 degrees divided by sine of 60 degrees, I get the value of side length C is 7.45 or 7.44. Whether you round or not, I don't care. So that will handle that. For this one, it's the same deal. Okay, I'll do sine of 60 degrees. By the way, I find students sometimes try to memorize, like, if I have this thing, how do I find C? Don't try to memorize it. Just do algebra. So I took the reciprocal, then multiplied. Just work it out. Don't just try to memorize something. Trying to memorize something will cause you problems because there's too many things out there to memorize. If you just learn a little technique, it handles all of it at the same time without any effort. So it's this over 9. And on the right side, I'll have sine of this new angle, this 14.21 degree angle, divided by little c. And again, I'm going to flip both sides. So I'll have 9 divided by the sine of 60. On the right side, the c would come up on the top, and then the sine of 14.21 would be on the bottom. I'm going to multiply that to the other side. And I'll get sine of 14.21 over there. And okay, I can compute that. 9 times sine of 14.21 degrees. Make sure you write DEG divided by sine of 60 degrees. And I get 2.55 as the side length. And that's it. So no problem is going to tell you in advance there's going to be two solutions or not. That's something you have to determine in the middle. And it's something you have to remember to try to determine in the middle. Okay, so that was that problem. Let's do one more. And then that'll be enough for this section, I think. So let's do one more problem. So this next problem, similar instructions. A is 44 degrees. Little a is 3. And little c is 23. Okay, so no problem there. Let's draw a picture. Let's see. So we have a 44 degree angle here. We have a side length 3 opposite of that. We have a side length of 23 somewhere, and then big C is across from that. Big B's here. Little b was not given to us. So, okay, looks the same as the last few, right? I mean, it's basically the same picture. I did call, little c the number instead of little b, but I mean, functionally that's no different. I'm still learning one side and not its angle. So, so let's look at an example. Let's work this out. So I'd have sine of 44 degrees. So I'm going to use this pair, obviously. I'm not going to use the pair of b's this time because they're both unknown. I'm going to now use the pair of the c's where one of the c's is unknown. So I'll have a 3 down here, and I'll have on the right sine of c, whatever that is, divided by 23. So just like before, I solved this for sine of c, and I'll get 23 sine of 44 degrees all over 3. So therefore c should be sine inverse, or arc sine if you prefer, 23 times sine of 44 degrees over 3. Well, let's compute that. So if I type this into my calculator, arc sine of 23 times sine of 44 degrees divided by 3. Look at my answer. This is a strange thing. Okay. Now this is in radians, but notice this I here. Oh, you don't see the I. One sec. Shrink this down a little bit. In Wolfram, you get this I here. That's the imaginary number, the square root of -1. And that's appearing here. Now, why on earth is that appearing? Well, if you had done this in a handheld calculator, it would have said error. It would have said this can't be done. Okay? But here you get this strange answer with an I in it that I showed you. And notice there's nowhere it says degrees anywhere, and that's because there is no there's no answer. Okay, this is an error. Your handheld calculators would just say, error, cannot compute, something like that. Why is this an error? What's going on here? Well, you have to remember the inverse sine, its job, as we defined it in class, was to tell you an angle in quadrants 1 and 4 with the property that the sine of that angle matched whatever you fed to it. But what is this quantity inside, this 23 times sine and stuff? Well, if we get rid of that stuff, we can see that the value of that inside is 5.36. So what you're asking sine inverse to do here is to find an angle in the unit circle, specifically in quadrants 1 and 2, with the property that the sine of that angle, the y-coordinate of the point that that angle touches, is 5. But in the unit circle, the biggest we get is a height of 1. 5.36 is up here somewhere. So there is no point on the unit circle with this property. So what's that mean? That means this is not a triangle. Not a triangle. You cannot solve it. There is no way to pick the angles B and C in a way that will make this side length 23. It's simply too long of a side. You'd have to pick an angle bigger than 180 or something to get that side length, but then you fail to be a triangle. So sometimes you run into this problem, and if you're using a handheld calculator, like I said, this would say error, or give you some kind of, there's trouble kind of message. Wolfram Alpha calculates it in a weird way. They use this imaginary number thing, and that's because there are in fact ways to talk about the sign of an imaginary number, and Wolfram sort of has that built in. That's functionality that you usually don't use until like a differential equations class or a complex variables class is where I teach it. But you just need to know how to interpret what you're seeing when you're using any resource, okay? And in Wolfram Alpha, if it gives you an imaginary answer with an I in it, then you know that that's that's an error, okay? That's the same thing that a normal calculator would call an error. So this triangle has no solution, and then you're done. There's nothing else to do in that problem because there's no solution. So we stop there, okay? And that's okay. So these 3 examples I did should cover most things involving law of sines.